Good morning, greetings students of Sabang National High School. I am here again to discuss uh, Quarter 1, Module 4 in Mathematics 10, titled Illustrating Geometric Sequence. Okay, so let us start. This topic is very easy. So since we are just going to illustrate what is a geometric sequence. So our topic is geometric sequence. So before we proceed with geometric sequence, let us take a look at our previous topics. Our previous topic is about arithmetic sequence. So there are several sequences. So let me just show you the difference between arithmetic sequence and geometric sequence. So arithmetic sequence is a sequence wherein we add common difference from one term to find the succeeding terms. So let us say we have 2 and the common difference is 3. So we have 2 plus 3, we have 5. 5 plus 3, we have 8. 8 plus 3, we have 11. Therefore, the sequence 2, 5, 8, and 11 is an example of an arithmetic sequence. In arithmetic sequence, there is a common difference, wherein you can find the common difference by subtracting any two succeeding terms. Let us say we have 5 minus 2, or you can say 8 minus 5. The difference will always be 3. In any succeeding terms, their difference is always is always the same. Sorry. That is about arithmetic sequence. So we are now going to proceed with geometric sequence. What is a geometric sequence? Okay. Let me give you an example of a geometric sequence. A geometric sequence, an example of a geometric sequence is 1, 2, 4, 8, 16. This is an example of a geometric sequence. Is this an arithmetic sequence? Their difference is 2 minus 1 is 1. Their difference is 4 minus 2 is 2. Their difference, the difference between 8 and 4 is 4. The difference between 16 and 8 is 8. So, their difference are not the same. So, the first two terms, their difference is 1. The second and third terms, their difference is 2. And so on and so forth. You have 1, 2, 4, and 8. So, the difference are not the same. So, therefore, we cannot call this as an arithmetic sequence since this is an example of a geometric sequence. How do we know that this sequence is a geometric sequence? Let us try this one. 2 divided by 1. The answer is 2. How about this one? 4 divided by 2. The answer will always be 2. How about this one? 16 divided by 8. The answer will still be 2. So, their quotient are all the same. So, meaning to say, geometric sequence is a sequence wherein each term is multiplied by a common ratio. We have the common ratio, which is, in our example, we have 2. In arithmetic sequence, we have common difference. We are subtracting two succeeding terms to find the common difference. In geometric sequence, we are dividing two succeeding terms to find the common ratio. So since we are talking about ratio, we are going to multiply a term to find the next term. We are going to multiply a constant number to a term to find the next term. So let us now define what is a geometric sequence. Since we have now an illustration of what is a geometric sequence, let us now define what is an geometric sequence. Geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term, by multiplying the preceding term by a non-zero constant, by a, okay, I would like to stress this one, non-zero constant. So remember that this non-zero constant is what we call the common ratio. So therefore, a common ratio could not be equal to 0. A common ratio could be any number. It could be a fraction, a whole number, a negative number, a decimal, except only for one number, which is 0. What will happen if the common ratio is 0? Later on, you will be able to figure out why 0 cannot be a common ratio of this geometric sequence. Okay, so let us proceed. Let us make an example, another example rather of an geometric sequence. Okay, so let us create an example of geometric sequence. Example. Let us say we have the first term, a sub 1. Let us say this is 3. And our common ratio, let us say our common ratio is 5. Therefore, to find the second term, a sub 2, is a sub 1 times the common ratio 5. Since our a sub 1 is 3, we have 15. Therefore, the second term is 15. To find a sub 3, a sub 3 is equal to a sub 2 times the common ratio 5. So this one is a sub 2. So a sub 3 is a sub 2, which is 15 times again by a common ratio, which is 5. 15 times 5 is 75. Therefore, a sub 3 is 75. Next, if we are going to find again the fourth term, a sub 4, a sub 4 is equal to a sub 3 times 5. That is 75 from a sub 3 times again a common ratio by a common ratio, which is 5. 5 times 5 is 25. Carry 2 on 7. 5 times 7 is 35 plus the 2 is 37. 375. So we have 375 for the fourth term. And so on, so forth. As long as we are just multiplying a common ratio, which is 5 in our example. So, to generate an example of a geometric sequence, we need at least the first term or any of the terms, then the common ratio. Okay, so next, in example number 3 in your module, it is said there that a ball bouncing is one of the situations that shows geometric sequence. If you are going to drop a ball, well-inflated ball, not just a ball, baka flat or mahina yung bomba ng ball, hindi yan magbabounce ng maayos. Yung well-inflated ball, each time it hits the ground, it bounces to 80% of its previous height. What will be the first 5 terms created by a ball that was dropped from the height of 100 inches? Okay, so a ball is dropped 100 meters, 100 inches from the ground. And as you know, when you drop the ball, it will bounce back, but it bounces back not the same height as you have dropped, as the initial height when you drop it. So, mas mababa yung bouncing back ng ball kasi mayroong external force na humihila sa kanya, yung gravity. So, it is said that the pattern is the ball bounces back 80% of its previous height. So, what is the first height? The first height, let me just erase this one. The first height, that is A sub 1, 100 inches. And the ball bounces back 80% of its previous height. So, yung sunod na height niya kapag tumalbog yung bola, bumalik sa taas, 80% na lang daw ng previous height. So, the previous height is 100. Therefore, 80% A sub 2 is 100, or rather A sub 1 times 0.8. Here, our common ratio is 0.8. 0.8 is a conversion of 80% into decimal. A sub 1 is 100 inches times 0.8. That is, A sub 2 is equal to 80 inches. So, the second term is 80 inches. What is being asked on this problem in example number 3 on page 5 of your module? What will be the first 5 terms? So we are going to need A sub 3, A sub 4, and the fifth bouncing back of the ball. So, to find the next bouncing back, the height of the next bounce, A sub 3, we then have A sub 2 times 0.8 again. A sub 2 is 80 inches times 0.8, that is 64, 0, isang decimal points. So we have 64 inches on the second bounce. Second bounce because 100 is the initial height. First bounce is 80, second bounce is 64. So, we are going to find the first 5 terms. Okay? So, A sub 3 is 64. Next, we are going to find, of course, A sub 4. That is, A sub 4 is A sub 3 times 0.8. So, that is 64 times 0.8. 64 times 0.8, 8 times 8, 16, 32, 2, carry 3, 8 times 6, 48, 48, 49, 50, 51. 51. So we have 51.2 inches. So we have 51.2 inches. And our last, A sub 5, A sub 5 is equal to A sub 4 times again 0.8. Our A sub 4 is 51.2 inches times 0.8. We have 51.2 times 8, 16, carry 1, 8, 9, 40. Oh, why is that? Dalawang decimal. We have two decimal places. So we have 40.96. 40.96 inches. So the height of the ball on the fourth bounce is 40.96. The fourth bounce is the fifth term of the geometric sequence created by a bouncing ball dropped from 100 inches above the ground. Okay. If you are going to notice, our formula becomes, let us say, we are going to find a sub 6. It is always that a sub 6 is preceded by a sub 5. So we have a sub 5 times the common ratio denoted by R. So what if we are going to find any term? So for any term, let us denote the term by n. So we have a sub n is equal to a sub n minus 1 times the common ratio, which is R. This will now be our formula for geometric sequence. Okay, let us proceed. Let us now take another example from our module, page 6 of your module. Example number 1. The problem is that give the first 5 terms. Give the first 5 terms of a geometric sequence whose first term is 7 and common ratio is negative 3. Okay, so we now have a common ratio which is negative 3. So a while ago, our common ratio are positive numbers. So let us take a look what will happen if our common ratio is negative 3. So based on the problem, a sub 1 is equal to 7. On our formula, which I have just written a while ago, a sub n is equal to a sub n minus 1 times the common ratio. So, based on the example, the problem, all we have to do is to give the first 5 term. So, the first term is already given, so we just need 4 more terms. The a sub 2, a sub 3, a sub 4, and a sub 5. Let us take a sub 2. A sub 2, since n is equal to 2, then we have 2 minus 1 times the common ratio. That is a sub 1 times common ratio. Or a sub 1 is 7 and the given common ratio is negative 3. So we have 7 times negative 3. The answer is negative 21. Therefore, a sub 2 is negative 21. A sub 3. Let us take a sub 3. So we have a sub 3 to make everything shorter for our solution. We now have here n minus 1. We have 3 minus 1. That is a sub 2. Times the common ratio is negative 3. The common ratio, or rather the value of a sub 2, which we have just computed a while ago, is negative 21 times negative 3. Negative 21 times negative 3 is positive 63. Therefore, a sub 3 is positive 63. You can write the sign positive or you can just write the number 63 for positive numbers. Okay, let us proceed with a sub 4. For a sub 4, we have, that is a sub 3 times the common ratio. A sub 3 is 63 positive times the common ratio, which is negative 3. Therefore, a sub 4 will become negative 189, with negative 189. And lastly, the fifth term, a sub 5, is equal to 5 minus 1 is 4. We have a sub 4 times the common ratio. A sub 4, based on our computation, is negative 189 times the common ratio, negative 3. So, we just multiply 189 times 3. 9 times 3 is 27. 2. 8 times 3 is 24 plus 2, 26, 2, 3, 5, 567. Negative 189 times negative 3 is positive 567. Therefore, the sequence now for the geometric sequence being asked is 7, negative 21, positive 63, negative 189, positive 567. If you are very observant enough to observe the sequence, geometric sequence whose common ratio is negative, you will observe that the sequence is shifting from positive to negative, negative to positive, and so on and so forth. That is, if the sequence is like that, they are now going to suspect that it could be a geometric sequence whose common ratio is negative. Okay, so a while ago I have that based on the definition of geometric sequence, 0 cannot be a common ratio of a geometric sequence. 1 can still be a common ratio of a geometric sequence. Thus, if we are going to take a sequence that is 2, 2, 2, 2, 2, 2, 2, this is still a geometric sequence where the common ratio is 1. So, if all the numbers in a sequence are the same, that is a geometric sequence where the common ratio is 1. Another, if it is negative 2, 2, negative 2, 2, negative 2, 2, this is still a geometric sequence wherein the common ratio is negative 1. What if the common ratio is 0? So let us say our first figure or the first term is 10. Therefore, if the common ratio is 10, rather 0, I'm sorry, the succeeding terms will become 0, 0, 0, 0, 0. This cannot happen as a geometric sequence because if you are going to find the ratio between these terms, the third and the second term, you are going to have 0 divided by 0, which is undefined or infinite. Thus, this is not a geometric sequence, and 0 cannot be, or r cannot be equal to 0. That is why 0 is not used as a common ratio in a geometric sequence. Okay, so let us take one last example, then the rest you are going to have your 10-item quiz. Okay, where's that example? Okay. On page 8 of your module, or rather on page 7 of your module, example number 3, supply the missing terms of the sequence. Supply you the missing terms of the sequence. of the sequence blank 10a squared 50a squared blank blank. Okay, so let us say that the problem is asking for a geometric sequence. Supply the missing terms of the geometric sequence blank 10a squared 50a squared blank and blank. So what is being asked is a sub 1, a sub 4, and a sub 5. What is given is a sub 2 and a sub 3. If this is a geometric sequence, then we are going to need the common ratio. A sub 2 is 10a squared. A sub 3 is 50a squared. Let us find the common ratio by dividing the two preceding terms, or rather succeeding terms. So, to find the common ratio, we can take a sub 3 divided by a sub 2. A sub 3 is 50a squared and a sub 2 is 10a squared. 50 divided by 10 is 5. A squared divided by, sorry, the third term is cube. So this should be cube. A cube divided by a squared is a. So the common ratio is 5a. Let us now take a sub 1. Find a sub 1. A sub 1, there is no such formula as a sub 1 is equal to a sub 0 times the common ratio, because there is no such thing as a sub 0. So how are we going to find a sub 1 if that is the problem? We are going to go back with the formula. A sub n is equal to a sub n minus 1 times the common ratio. Let us say that this a sub n is, let us make that as a sub 2. Therefore, this one will become a sub 1 times common ratio. We know that the common ratio based on our computation is 5a. Thus, a sub 2 is 10a squared is equal to a sub 1 times 5a. A and a sub 1 are two different things. So, you cannot multiply that one. You cannot write this as 5a squared. All we have to do is to divide both sides by 5a, so that 5a on the right side will cancel, and what is left is only a sub 1, which is what we are looking for. So we have 10 divided by 5 is 2, a squared divided by a is 2a. Therefore, the first term is 2a. That is how we find a sub 1. You can do the same with the other terms in a sub 4 and a sub 5. So we are going to find a sub 4. A sub 4 is equal to a sub 3 times the common ratio, which is 5a. A sub 3 is 50a cubed times 5a. Therefore, a sub 4 is equal to 250a to the 4. Therefore, a sub 4 is 250a raised to the 4. And lastly, a sub 5 is equal to a sub 4 times the common ratio, that is 250a to the 4th based on the value of a sub 4 times the common ratio is 5a. So we have 250 times 5, 125. Am I right? Tama. So 125, 0, 1250 a raised to the 5th power. So therefore, the 5th term is 1250 a raised to the 5th power. Okay. So let us now write the answer for this problem, the first 5 terms now is 2a, 10a squared, 50a cubed, 250a raised to the fourth, and 1250a raised to the fifth power. Okay, so that is the solution or the answer for the example number 3 on page 7 of your module. Okay. So that will be all for now, since our topic is only illustrating what is a geometric sequence. So may I just reiterate that a geometric sequence is a sequence wherein the succeeding term is found by multiplying a common ratio from the preceding terms, from any preceding terms. Okay? So for any questions, you may just message me on our GC, or you can message me privately. Thank you very much.